Good morning. Here we're going to have a look at 2015, question 10, part A. Now, this is actually not too bad. It's nearly slightly confusing because you might think the first part is so easy. So we'll work our ways through that, and it's a good bit of practice about working with distance and time. All right, and finally, a little bit of thinking in your graphing. I'm going to look at two different ways we can address this. One from understanding what the ones look like, and the other one if you don't. So, part one. All right, part one is the speed of the cars after 4 seconds. Well, we know that VA equals t squared, and we know that VB is a little bit messier, 6t minus 0.5 t squared. Well, after 4 seconds, it is literally as easy as it looks. We're just going to sub in t equals 4. So VA equals 4 squared, 16 meters per second, and VB equals, and we'll just write that out, and that is 24 minus 8, and that is of course 16 meters per second. How about that? So they're both going the same speed, and this is setting the scene for things a little bit later on. Now, what you'll probably begin to guess is they probably traveled different distances because they got to that speed in different ways. Okay, and now of course we're finding the distance. So for part two, now be careful here, we're looking for the distance between the cars, all right? Now you can have a bit of a guess in this one. It actually doesn't really matter if we're wrong. Let's just say SB minus SA, okay? That's the distance between them. Strictly speaking, it's the absolute value of SB minus SA, because at this stage, I'm not going to worry too much about which one of these is going to be going faster. All right, so we just flip the sign at the end of it. Now, what we've got to find out then is SB and SA. Well, this is a bit we need to know. Velocity is ds dt. All right, velocity is the rate of change of distance over time. All right, so that is how we're going to figure this out. So for SA, okay, we are going to use the fact that ds dt is velocity, so that is t squared. So ds equals t squared dt. I'm going to integrate both of those. Now, what limits are we going to use? Well, we know that if you go back to the question, you will see they start from rest. So those are both 0 at the bottom. All right, we are looking for SA there, and that means we're looking after 4 seconds, so that's our limit number 4 there. All right, so we have S, limits SA and 0, is t cubed over 3, limits 4 and 0. This is nice and handy stuff, and that is 64 over 3. All right. I'll leave it as a fraction for the moment. Meters, of course, don't forget that. All right, next one here, SB. Okay, it makes it work a little bit more for now. So ds dt is 60, not that much more now, but a little bit more, t squared. So ds is 6t minus a half t squared dt. Integrate both of these, and just before they start from rest, at time equals 4, we're looking for SB. All right, so we end up with S, limits SB and 0. And now let's just go through this nice and carefully. That's going to go to t squared over 2. So that is 6t squared over 2 minus 0.5 t squared, so that's going to go to t cubed over 3. So that is, we'll just do it as t cubed, and that's over 2 over 3 is going to put it as over 6. All right, and our limits here are 4 and 0. A little bit of working out. SB equals 6 by 16 over 2 minus 64 over 6. We figured that out. I think we'll squeeze another line in here. SB equals, you can do this in your head, you can do it in a calculator. I mean, that's going to be 3 by 16. Let's set 3 by 16. Again, you can probably figure this out. Of course, it's 48. Stick it in just there. We go. We can see that. Minus 64 over 6. Okay, and there we get 112 over 3. And I know loads of you doing this, there are all sorts of maths quizzes and you can fly through these things, there we are. But if you're under a little bit of pressure in an exam, you know, I would find more often than not, you're going to make a slip in the calculator and it's no harm to just throw that one in. Okay, on the same graph, so that was part 2. Now this is the one we might think, whoa, what is this about? We want to draw these two things. So we're looking for a graph here, and that's time. And what graph are we looking for? It is a speed time graph. So that's speed, okay? I'm going to call it V because that's what we're using in ours. There we are. All right. So what are they going to look like? Well, we know a certain point of them. We know when that's 16, that's 4. So we go back to the very beginning of our question. They're both going 16 meters per second. So they're both going to end up here. And they're both going to start here. So the question is, how do they get there? Now, method number 1, you might look at this and you might see VA is t squared, and t squared is going to go up like that. All right. And you might figure the other one is going to start off and it's going to begin to poke away because it's minus t squared. So it's like a negative quadratic. This is the kind of one you might get on it. All right. And you could shade in the area here. Remember the distance between the two cars is this distance. Okay. It's the total distance of the top one all the way down to the line minus this distance here. So we get left at that bit. Now, what if you didn't see that? And I wouldn't be freaking out if you didn't see that. In this case, we're going to do it by brute force, and it's not all that hard actually. Because what we're going to say is SA, SB, make a little table here, and this is time 0, 1, 2, 3, and 4. All right, so it's 0 at the beginning. Again, we're just going to stick some numbers in here really nice and quickly. So if we look here, this is SA is nice and easy. It's t cubed over 3. So in this case, it's 1 over 3. In this case, it's 8 over 3. 27 over 3, which equals 9. And then we know it's going to go to 16 at the end. Okay, SB is a little bit funkier. It's this guy here. But again, we're dealing with fairly nice numbers. So 6 over 2 minus 1 over 6. Just punch that in again. I know you can do it in your head, but let's just not give ourselves too much to worry about in an exam. Minus 1 over 6. That's 17 over 6, so 2.83. It's a little bit easier to deal with this one in numbers. You can see 0.3, 2.83, big difference after 1 second here. That is, of course, let's stick that into numbers. 8 over 3 is 2.6. All right, what's this one going to be here? I know there's a little bit of work on this one here. 2 squared is 4, so 24 over 2, so it's going to be 12. Minus, do this one as a fraction, 2 cubed is 8 over 6. And we're going to get to 10.6. And again, 3 here. Okay, as you can see, this is going over 6 by 9 divided by 2. So you can do these in different ways. Minus 3 cubed is going to be 27 over 6. 45 over 2, 22.5. So what we'd do is, and then you just draw your little graph and do a really rough plot. Remember, it doesn't have to be perfect, but a rough plot, and you can see very clearly the kind of different shapes that are going on with this one here. All right, something definitely went wrong with that last one. So we'll just go back and recheck that. Can't be more than 16. But you can look at this, you can kind of get the idea here. All right, that's how we're going to have a crack at it if we can't see it. It only takes a few minutes, so don't worry about too much about these things. Brute force sometimes works very well.